Start.
Dear students, today we are going to learn speed control of DC motor using digital PID controller. Okay, so here our main objective is that to control the speed of the DC motor. So before start this experiment, we should know what are the components involved in this trainer kit. Okay, so generally this system composed of three major components. One is permanent magnet DC motor setup, then digital PID controller kit, then DC motor trainer kit. So these are the major part of this experimental setup. So now we are going to learn how to control the speed of the motor. Okay, so here so this is the digital PID controller. Here we will enter our input value. Okay, based on the input value, this system will perform our required speed. Okay, so here we go. Number of options such as increment, decrement, reset, back, enter, then set on. Okay, so we can 6 number of options. By using these options, we will enter our program into the system. Okay, first here we got two options. One is increment. Okay, that is normal PID. Then D is represents square root. Okay, so here I will go with INC. Okay, INC, that is normal PID mode. Okay, just press this button. The next we have two options. One is auto mode, then manual mode. Here I will move on to auto mode. So again press the INC button. So press here. Okay, press this arrow button like this. Okay. Now we are going to define the speed of the motor. So generally the maximum capacity of this motor equal to 1500 RPM. So here I will enter 1500 RPM. Okay, like this. So by using our back button, so press this back button. So now this cursor is reached to this location. There you increase the value from 0 to 1. Again press the back button like this. Now the cursor is at this location. Okay, the cursor is at this location. Here raise this value up to 5. Okay, so by means of using this button, raise this value 0 to 5. Okay, now this is the maximum capacity of the motor. After enter this value, okay, after type this value, just enter this, yeah, by using this button. Okay, just enter. Next, okay, after entering the maximum capacity of the motor, okay, next we are going to define our speed of the motor. Okay, at what speed this motor to be rotated. Okay, that speed range should be decided by ourselves only. Okay, you may select any value. You may give value less than 1500. So within that we will take any value. So here I will take around 400. Okay, at 400 RPM this motor to be revolved. Okay, so that is a target. So that will be achieved now. So here I will set at 400 by using the back button. So press the back button, then raise the value from 0 to 4. Then again press the back button, then raise the value to 4. Sorry, 400. So make it as 0 simply. After type this value, just to enter this. Okay, just to enter this by using press button. Okay, now we have to enter the 3 unique value. Okay, that is KP value. That is KP is nothing but proportional constant. Okay, the main theme, okay, main impact of this factor is nothing but, okay, when we increase the KP value, then system reaches our target value within a very short span of time. Okay, within the very short span of time, the system reaches our 400 value. If you increasing the KP value, okay, suppose if you decreasing the KP value such as 0.5 or 0.2, that time this motor reaches our required speed by taking 1 or 2 months also, because we are giving very lesser value. So this is the main okay, these are the main importance of KP value. This KP value increases means the system reaches our target within the short span of time. Okay, the main importance of proportional constant is nothing but when you increasing the KP value, the system reaches our target value with a very short span of time. Okay, suppose if you increase in the KP value such as 0.1 or 0.001, that time the system reaches our required speed. It takes around 1 or 2 days also. So here I will enter this value approximately 3. You can give any value based on our convenience. Okay, if you have more time means you can give lesser KP value. Suppose if you have lesser time means you will give more KP value. So here due to demonstration I will give a nominal value as 3. Okay, here I will give a nominal value as 3. Okay, so by using back button, so here I will enter 3. After set this, just enter this one. Next one is ki. K is nothing but integral constant. Okay, integral constant or integral gain. Okay, so this value taken as any value. Okay, so the importance of this ki and kd values are, it is used to okay. So okay, now I will explain what is the importance of integral factor and integral gain and differentiative gain. Okay, so before that I entered Kp, that is a proportional gain, as 3. Okay, suppose we increasing the proportional gain to 10 means, for example, okay, so these in the x-axis I will take time, in the y-axis I will take speed. So here the maximum capacity of the motor equal to 1500 rpm. Okay, our required speed is 400, like this. Our required speed is at 400, this motor to be run constantly. That is our target in this experiment. Okay, okay, after giving all the input value, this motor start to rotate from 0 rpm to maximum rpm, like this. Okay, it goes to like this. Then again it come down, then again it's go like this. Okay, after taking some time, it reaches the 400 rpm. So if you increasing the Kp value as 3 means it takes this much amount of time. Suppose if you take Kp value as 10, that time, okay, within this time, okay, within this time the system reaches our required speed. Okay, it takes only few time for its to obtain our target value. Suppose increasing the Kp value as 0.001 means it takes 1 or 2 months also to obtain this speed. Okay, that is the importance of Kp value. Next, okay, next is what is the importance of integral gain value. Okay, it is nothing but, okay, based on the its integral is nothing but, okay, before explain the integral gain, I will explain differentiative gain. Okay, because okay, this function is worked based on the existing process outcome. Okay, so this is the existing process outcome. Here I will take number of points on the graph, is 0.1, 0.2, 0.3, 0.4. I will take number of points, then I will construct some lines. So it's small change, okay, dx by dt. Okay, in this small from this equation, in very small second, how much instability occurred in the system. Okay, based on the instability, okay, we are going to control this system. Okay, when the system reaches, okay, see here, suppose when the system reaches at this point, okay, at this point, okay, so at this point the system not attain our target. Okay, it going to be attained. Okay, when the system reaches at this point, that time this differentiative constant comes here, okay, to slow down the process. Okay, to stop these events. Okay, so that is a role of differentiative gain. Okay, then the integral gain is nothing but is a future. Okay, at where, okay, at what distance, at what time it going to be obtain our required time. Okay, so this line will be split into number of small segment, then it is integrated into integrated to its full length. Okay, so from this we will obtain at what time or at what distance it will reaches our target value. So these are the importance of these 3 values. So now I will enter this value into the trainer kit. Here I will take Ka equal to 0.1. So here I will make it as 1. So use back button, make it as 1. After obtain this value, just enter this value. I enter. Then now the system is asked derivative gain value. So here we take as 1. You may take any value. For our convenience only, I take 1, 3 and all. Okay, you may take any value based on your time constraints. Okay, here I will take 1. Okay, after feeding all our input, okay, enter this. Okay, now see here, the motor is start to rotate from 0 rpm to maximum rpm. Again it's slow down, again it goes to peak value. Okay, after it takes some time. Okay, like this graph. Okay, like this graph, it goes 0, maximum, minimum. Okay, after reaching some distance, this motor reaches our required speed equal to 400. See here, this value is varies from 399 to 400. So now after the short span of time, because here I give kp value as 3. Suppose we give value equal to 1.5 or 1 means it takes around 1 minute or 2 minutes to obtain this speed. But here the less than 1 minute the system reaches our target value. Okay, thank you.